Today in class we are doing a lab where we are determining the chemical formula of an anhydrate and a hydrate. So right now we're using copper sulfate pentahydrate, which is CuSO4 and then 5 water molecules. And what they're doing is essentially burning off the water part of it, the hydrated part of it, and to determine how much of the water was burned off, what was the molar mass of the whole compound, the formula compound, when we have the anhydrous form and hydrated form, and what were the percentages between the copper sulfate as a hydrate and how is it as an anhydrate.
Hydrates and hydrates.
Yeah,
Alrighty.
It's a little bit blue.
oxidation. We're not affecting the copper sulfate, right? We discussed yesterday that our water is going to boil, right, at 100 Celsius, but our copper sulfate, I think Laura looked it up yesterday, it was like 3,000 is the boiling point for copper. Yeah.
Does it mean that we need to divide it by this one?
Correct, yeah, because we're trying to find how many moles of anhydrous we have. So whatever you solve for the burned off version of it, that grams, you want to convert that into moles by it. Say again? You changed it from blue to white. Does anyone remember why? Tim?
Because water is evaporating.
The mass of the salt divided by the molar mass.
Yeah, the mass of the salt divided by the molar mass. So a lot of you were right around 4.5, 4.6, 4.7 with your grams. So the question on number 4 said, would you expect the number of moles of your hydrated copper sulfate and the number of moles of your anhydrated copper sulfate to be the same? Why or why not? Who answered that already? Chantel?
It stays the same because when the water evaporizes, the molar mass changes and the grams changes. They both change. So when you calculate it, it would still be the same.